let's go ahead and keep going. So this presentation is going to be by somebody who enjoys designing intuitive products, somebody that likes to make products that make our lives easier. I'd like to welcome up to the stage Ziad from Ivy Wave. Ziad, come on up.
Hey everyone, welcome back. Well, as you know, any new technology faces this period of questioning. Will that technology be useful for us or not? And AR and VR is the same thing. It's not escaping that paradigm. And hopefully now we're beyond that questioning period. If it is relevant or not, and some interesting use cases in the business we're seeing some interesting use cases for that in the business. But today here together, the topic of this presentation is to see together whether it is relevant to us as wireless professionals, and if it's relevant, how does it really affect our daily lives as a wireless professional going about doing some designs. And just a quick show of hands here, how many of you have done any designs for AR or VR applications, or have been asked to do any designs for AR and VR applications? So see one, not a lot of you. No, I wasn't two, all right. So maybe 1% or 2%. How many of you think in the next year or two you'll be asked to do a design for AR and VR application in the industry or manufacturing? A bit more. So this is what we're expecting, kind of ramping up these use cases we're going to be talking about in the industry. Another question for you: how many of you here think AR or VR is going to be helpful for you in accomplishing your day-to-day task as a wireless engineer or wireless designer? Or a little bit more? Maybe about 15, 20%. Well, hopefully here together we're gonna have an open conversation in the end. You can come and see me after. We can talk more about these topics. So just a quick trip down memory lane. How did it start? Well, the notion of having an enhanced experience is not a new one. And a gentleman by the name of Morten Heilig, back in '57, devised this contraption where you can go and sit and experience some virtual trips or different kind of. I think he had up to 5 or 6 kind of different experiences you can live through that. He kind of devised his machine to mimic, to give you feedback and solicit 4 of your 5 senses. And I'm sure if he tried a little bit harder, he could have added the 5th sense, the taste sense, by doing maybe like a hot dog feeder that gives you the full experience of eating hot dog at Coney Island. But it's kind of like start of this journey. But then in '65, things got a little more interesting and more serious at Harvard University with Dr. Sutherland and his team, where they started looking more at how not just giving you feedback in a way that in a passive way, but actually kind of overlaying a synthetic image in front of your field of vision. And they devised this early prototype of sword of Damocles of a wearable. And you can see here sword of Damocles why it's called that. And it's really the beginning of the whole math and how you interpose kind of an images in 3D and then how it reacts to the movements of the position of your head and how you're looking. Obviously, they were limited by the technology of the day. They had to be tethered, and so it wasn't the most elegant way, but really it was the foundation of today's AR and VR, where we are now using the technologies that we have in terms of battery progress, in terms of display progress, in terms of also latency on the wireless side, something we're going to be talking about a little bit later as well. So you have basically 2 kind of solutions today for these technologies, whether that be wearables or be handhelds. And one thing that also this allows is interaction between people, no matter where they are. So if you are somewhere here and somebody else is halfway around the world, you can project kind of the same synthetic image, a copy of the same synthetic image on both displays, and then have this kind of interaction or similar experience with that person halfway around the world. And what's happening in the future is this synthetic image that is more of a copy now in this collaboration. In the future, it's going to be more of a real, it will be the same image, projected image, synthetic image that you're seeing if you're collaborating with people in the same room. It will have kind of this Princess Leia talking to R2-D2, kind of that projection kind of experience. And that's exciting in terms of allowing people to share the exact same level of detail or same level of interaction. So let's look at designing for XRs. Maybe about 2% of the people here said that they already did this or they're thinking of doing it. But let's look at what it means in terms of wireless design. Some of the use cases that you might be encountering in this short-term future would target the warehouse operation where navigation is going to be aided by some AR. You're going to have some fill rate and some other information overlay that would help in the operation. Some other example of application in retail, where the consumer comes in and the shopping list is already mapped out through a virtual path. They can follow that, and also the retailer can provide some extra information about promotions that they're doing or some other use cases like that. Industry 4.0, we heard a lot about IoT. We heard a lot about machine learning and AI the past few days. You bring those together with big data analytics, and then you have this kind of business intelligence happening, and ways to improve your production line, ways to improve the way you do business in the industry. And having AR and VR would actually close the loop. And then if you have somebody going down on production plant or manufacturing plant with an AR overlay, you can see some metrics, can adjust some values, some parameters, and see how the plant is reacting real time. So exciting stuff there too as well. Remote assist is another use case where AR and VR can be very helpful. Somebody who's in a remote area maybe doesn't have the knowledge or the expertise to accomplish a specific task, and they don't have the means to travel somewhere where they can acquire that expertise. What they can do is they can call up some expert, and through AR, they'll be guided onto exactly what they need to do, whether that be fixing an engine or doing some medical procedures remotely. Another field of application would be in education. And imagine just how much easier it would be to communicate some abstract notions to students using some AR or VR and collaborative methods. So these are kind of use cases. Maybe there are others. I'm sure there are others. But what they have in common is in terms of what they need from us as wireless designers. So we need to now be more cognizant of latency. Latency is very important in these applications. Throughput as well. More also the behavior of throughput when you have some burst conditions happening. So how does latency react to bursts of throughput? And obviously resiliency if you're dealing with Industry 4.0 or medical applications. On your air interface, you need to be careful that you have some good design, resilient design. So we've seen a little bit how our daily job can be affected, but how about now using this technology to help us do a better job? Is there a way we can do it? So you look at IBWave, we look at more at technology as something that is helping the expert, you guys, the innovators, to achieve and communicate your vision of a very reliable network. So whether that being in 2003 using some top-of-the-line ray tracing algorithms to do our predictions, or using cloud services to enable you collaborating with bigger teams and bigger number of projects, or in 2012 with mobile helping the field engineer do better surveys and communicate better with the RF designer back at headquarters. So now, looking at this new technology, we're investigating ways how this technology can help you, achieve and communicate your vision to the network owner, to the installer, to other stakeholders around you. So what are some of the use cases we're looking at? One of them is design, previewer design. Some of you might have seen this video that we shared back in February. And this use case here has been dubbed, I think, the controller on a chair use case by some of the people because of that. There you go. And so one of the things that when you do your design, you want to share it with the installer. You want to share it with the owner of the building. This is how it's going to look. This is where we're going to go and put our cabling. Yes, no, sign here, please. You get your sign off on that. You don't need to go back and then fight for it. The conversation will become much easier. Another use case that you're seeing here is when you're installing equipment that you might have, like some panels or anything like that, you can overlay some the inside of the panel, what's happening inside, if you're doing connections or connectors, and see position of the connectors and how you're doing that. Another use case is if you're doing an IDF, some racks in IDF and MDF, you want to make sure that they fit together, and whatever you're putting in the racks, you're sliding in, you have space. So that's one of the things that also the AR can help you with it. All of this you can record, obviously, and then send to the installer for them to keep as a record for what they need to be doing. Another use case we're looking at is situating yourself in a building. You walk into a building, you have a floor plan. Usually you go and you're doing your survey, you have to point on your tablet. If you're lucky, you have a tablet. If not, you have a PC, and then you're doing that with a mouse. It's not really very straightforward. And then you're doing your survey, you're taking measurements, you're taking videos, annotations of things around you, but then you have to say where you are. So you don't need to do that. With AR or with some of the uses we're looking at, you have kind of an automatic positioning. And please don't mind the Pac-Man here. What I did is I tagged one of my colleagues, a pesky colleague, because they're always following. So just I know where they are whenever I'm in the office. So as you can see, it's pretty accurate. You see the bottom right. Oh, here's the pesky. Oh. So you see it's pretty accurate. You go in the hallway, it follows. I don't need to tell it anything. It's just doing it automatically. And one good thing about this solution is that you don't need any external infrastructure. So everything is done on the phone. So if you go in a green field in a building that doesn't have any Wi-Fi or anything, you just turn this on and you know where you are. Here you see on the bottom right, I'm walking through a wall, but the wall is not there. But many of you have been in this situation, I'm sure, where you go to a building and you have an old floor plan. And because this is what they gave you, and what do you do with it if you want to do some predictive design or anything like that? So maybe one other use case that you can use AR for is remodel your floor plan. So if I take the same floor plan here, outdated, and the conference room that you see there that was not present on the plan that I have, I can either go on a piece of paper and measure and then note the distances and everything on a piece of paper, or I can use AR and without calibration or anything, and just trace on the floor plan my walls. I will get the measurements, I will get the distances, and also I can look back at this video and then see, okay, well now I'm rebuilding this floor plan because it's outdated, but here there's glass, here there's a door, here there's sheetrock. So I can also use that as a reminder of what material, if I want to do some propagation and associate some propagation loss to these materials. So that's something you have, and then you can just save it, and it will update your floor plan accordingly. Another use case we're looking at is locating your equipment. So let's say you're going in for maintenance or operation, and you need to locate some of the equipment. Is it above a drop-down ceiling, or is it on the floor mount? Is it wall mount? Where is it? And I have maybe 20 to locate, and do I have time really to go and see myself where I am in the building? Or I can just here, for example, select 3 access points on a floor plan, and then I can follow directions to go find them. And then here you see one of them in the distance. And you can add some extra intelligence on top of it, where when you get closer to a certain one, like the green one, now the whole circle becomes green, telling me I'm closer to the green one. If I look at the green one, so I have an icon that drops down, tells me there's an access point above the drop-down ceiling. And I can go even more, click on that icon, and if I had modeled the real access point, I can see that access point with the ports. I can see which ports are connected. I can also see maybe an overlay of some operation data, how many clients on average per hour are connected to this specific access point. What is the utilization of airtime utilization that this access point is seeing? So all of these information, they can become very accessible to you when you're there on site. Another use case we're looking at is visualizing the RF propagation. So many of you here, I'm sure, you know if you know an AP is in this corner of this conference room, you probably kind of imagine how the propagation goes in this whole room, and then how it goes outside of this room, how it's attenuated. But if you go to a building owner and you tell them, oh, I did my survey and I need to add more 4 more IPs on this floor. It's like the building owner might tell you, why do you need that? And you show him maybe a floor plan with your heat map. Maybe it's not really very obvious. But then you show him this, and then you're there with him in his office in the critical areas that he needs, and you show him, oh, you have a dip there. That's why. Then suddenly that conversation becomes much more easy. You don't need to explain yourself too much. You can overlay your predictive heat map. You can overlay your measured heat map from survey. You can subtract these 2 heat maps and then overlay just where you have a big difference between your predictive and your actual coverage. And then when you go there for your validation survey, you just concentrate on those areas where you see a bigger difference. Why is my predictive much more different than my actual? Did somebody put metal shelving there since I came last time? Is there an extra wall that they built? Is there lead lining if you're in the hospital? You don't know, right? But then it makes that conversation much easier. It makes that cycle to fine-tune your design much faster. So these are kind of a little bit some of the use cases we're looking at. And the purpose here is to see with you guys, anything that you saw here today, do you feel that it will help you? Do you feel it's something that is useful for you? If yes, come and see me. If not, come and see me and tell me so. And we can take it from there. Hope you enjoyed it. Thank you.
Wow, Ziad, that's some super cool stuff. Thank you for that presentation. So let's go ahead and take some questions now. Oh. First one is, what does this require to work? CAD?
No.
No CAD required?
No CAD required.
Wow.
Yeah.
Just a 2D floor plan and off you go.
You have a 2D floor plan, you take your device, you calibrate it, and there you go.
Wow.
Yeah.
Any other questions? Further questions? One thing that reminded me of, anybody play racing games ever? Like, I don't know, Need for Speed 3 is one I played a lot back in the day. And basically anyone with a mini-map. You guys remember you'd always have a mini-map down in the corner? That's what that reminded me of, was the mini-map. So, yeah, pretty cool stuff.
I never played that, but it sounds...
You should. It's fantastic.
Yeah?
Really good stuff. Well, awesome. Thank you so much. Let's give it up.
Thank you, guys.